Solve each system of equations without graphing. Okay, so I'm looking at this first system, and I basically, since I can't use graphing, that means I can either use elimination method or substitution method. And if I look, I see that I have the same coefficient, but I also have the same sign, so that means I can subtract the two equations. So now I'm looking at the coefficients of the y term, and I see that I have a 4 and a 3. So if I subtract the second one from the first one, 4 is a bigger number, so I'm going to be getting a negative. So what I'm actually going to do is I'm going to take this first equation, I'm going to put it on the bottom. So I'm going to do it like this. And then that way, when I do the subtraction, I'm going to have a positive value for the coefficient of y. So when I do this, 2x minus 2x, that's 0x, so that's nothing. 4y minus 3y, that's just y. And then 9 minus 5, that's 4. All right, so now I figured out what my y value is. Now we can plug it into one of these equations. We'll plug it into the first one since it's got smaller numbers. And we'll have 2x plus 3. And I'm going to replace that y with a 4. And then that's going to be equal to 5. All right, so 3 times 4, that's 12. So I'm going to have 2x plus 12 equals 5. Now we can subtract 12 from both sides. And we're going to get 2x. These cancel. We're going to get negative 7 here. And now we can divide by 2. So that these cancel, and then we will get as our x value, x equals negative 7 over 2. So our final solution should be written as a coordinate. We're going to have negative 7 over 2, comma, 4 as our solution to the first system. So now we move on to the second system. Now for this one, I see that I have opposite signs and the same coefficient for the y's, so this means I should be able to add the systems directly, and then the y's will cancel each other out. So 2/3 plus another 2/3 means I have a total of 4/3 x. The y's should cancel, and then I'm going to have 1 plus 7/3. Okay, so this is going to be a little challenging because I've got different denominators. So I'm going to change the 1 into a 3/3. Now I've got 3/3 plus 7/3, that's equal to 10/3. Okay, so now I can divide both. Well, I've got x, it's being multiplied by 4/3. So I'm going to just divide by 4/3 on both sides. And I know that when I divide by 4/3, when I divide by a fraction, that's the same as multiplying by the reciprocal. So instead of dividing by 4/3, I can multiply by 3/4. So I'll take this from the bottom and move it to the top like that. And now I can make these 3's cancel each other out. So, and these over here cancel, the 4/3 and 4/3 canceled out. So now I've got x on the left, and I've got 10 over 4 on the right. Now I see that both of these are even numbers, so that means I can divide both of these by 2 to get 5 over 2. Okay, so I've got my x value now. Now I can plug that into the original equation. I'm going to pick the top one because it had a positive y. So I'm going to have 2/3, and instead of x, we can put now 5 over 2. And now we're going to have a plus y equals 7/3. Okay, so I see here that there's a 2 on the top and a 2 on the bottom. So these can cancel each other out right away. And now I'm going to have an equation that looks like 5/3 plus y equals 7/3. So now y has 5/3 being added to it, so now I can subtract 5/3 from both sides. So these should cancel, and then I'll be left with y equals, so I've got 7/3, and I'm subtracting 5/3, that means I have 2/3 left. So my y value should be 2/3. When I write this as a coordinate, this should be x, the x value was right here, 5/2. And the y value was right here, that was 2/3. And there is our solution to the system.